So let's say that you want to use SAP in order to chart a group of kits, but you have a lot of data to put into the right format to create the text file for SAP, and the idea of putting maybe a group of big Ys, Y500s or Y700s, and getting all the STRs out and the SNPs that are necessary and putting them into a SAP input file is not an easy task when you have a lot of data. Plus, the available analysis that you get out of the family tree DNA reports is basic. It's good, but basic. And maybe you want to get a little bit more analysis of the SNPs that separate your group. Those things are what the CSV analysis function is intended to provide. It will automatically generate the STRs and the SNPs that will go into the SAP tool itself. You can take that output and plug it directly into the SAP tool. It will also give you some tables that explain the SNPs that are found in a group of big Ys, either Y500s or Y700s. You can put both of them through this. So I'll show you how to use that tool, the CSV analysis tool, in this video. I'm not going to cover the functions of SAP itself. If you want to know more about the SAP tool, please refer to some of the other training videos that we have on that subject. So the first thing you're going to need is all of the CSV files for your groups, STRs and SNPs, all in one folder, like I have them here. All these YDNA, DYS files are the STR results from these kits, and the big Y data, obviously, is the big Y data. Either Y500 or Y700 is all in one place so that I can run those through the tool. Now, to get that, you go back to your family tree DNA screens, and that can be found either here under the YSTR results for your YDNA, or here the YSTR results for your big Y. They both have the same files. If I click on either of these, I get my screen with all my YDNA results for my STRs. I scroll all the way down to the bottom, and there's a download CSV file button right here that I can click. If I click that button, it will download my CSV file just for my STRs. If I go back to my big Y screen and I click the results button to get to that tab, under either the named variants or the unnamed variants tabs, there's this export CSV button here at the top. They both produce the same file. Do not click the matching report and try to export that CSV. That only produces a CSV file of your matches. Doesn't produce very much data, and it's not very interesting for analysis purposes. But either the named variants or the unnamed variants tab, whichever, have this export CSV file button, and you click on those and it will download that file for you. That's a larger file, by the way. It will take a little bit of time to download, but it's nowhere near the size of a BAM file that you would get by downloading your raw data itself. So those are the CSV files that you need to gather. Once you have those, you put them all into one place. If you're a project admin, you can get these for your group by going into each kit and exporting those files. If you're not a project admin, you'll have to ask your matches to send you those files. Either way, you gather the files together, you go back to the CSV analysis tool, and you select the Choose Files button, which will bring up selection criteria. You go in and let's say out of these, I'm going to select the first few that are STR only, and then I'm going to select this one with its STR data. I'm going to come down here just for demonstration purposes. Also select kit 80341 there, both the STR and the SNP data. And I'll do this one as well because I have that one. And then I run those. It says I have 9 files. Now, I have 2 options I can choose here. There's a checkbox that allows me to choose the options. The first one is to only report SNPs in quality regions. I'll talk about what that means when we get to the tables that the tool shows. And the second one is to report only SNPs found in all tests. In a lot of cases, some of the SNPs may be no-called in certain tests. They might not have been covered, or the reads were not reliable. And so a lot of times a SNP will not be covered by all tests, and this option allows you to limit the reporting to only show the ones that are. I'll do that for now, and we'll execute the tool. First thing it does is it uploads all my data. Now, if you chose a lot of files, this can take a while. It's going to take about a minute for me here with these 9 files, but obviously if you're running a lot of snip files, especially because those are larger, it's going to take some time to upload. If you're on a very slow Wi-Fi or something, it may even time out, so you might want to get a faster faster connection if you're going to use this for large amounts of data. But it then runs here. The tool also will take a while to run, especially, again, if you have large amounts of snip data. It will give you some regular status messages about what it's doing, but you can expect on this kind of data with 3 snip files in here, it's probably going to take about 10 minutes to run. It could take half an hour or more if you're running large amounts of data, but it does go a little slower on the first few snip runs, and it goes faster on the others. Because it's setting up some initial conditions here. One of the things that it starts by doing is it checks a database of almost 800,000 snips that are very gratefully that were provided by YBrowse. Those will give it the position references for all of the snip labels that are included in the CSV files, for instance. So here's a status message. It just finished the first kit. It's running on the others. I'm going to fast forward through this so that I can show you the end here. So I'm going to pause the video now, and we fast forward to the end of the run. There are some status messages first as it was processing all of the input files, and then I get 3 tables here. The first one is just the kits that I read in, the STRs and the SNPs that I read in, as a double check that I can look at and just make sure that I did read in the ones that I intended to. So for each of these, I did get both the STRs. There's 561 in these 3, and I got the SNP files. For these, they don't have any SNP files, but I got all of their STRs in. So that's just a double check for me on the input data. And then it gives me tables of subclade SNPs and private SNPs for all of my kits. Now, to understand these, I have to flip over to a little slide that explains branching structure and where all these SNPs fall. So obviously a private SNP is one that is only on a single person's line. So if I branched off here from the rest of the group, SNP 2 is private for me, SNP 4 is private for match 2, SNP 5 is going to be a private SNP for match 3. Shared SNPs, are the ones obviously that are shared by the entire group. So that may change if I expand my group and add more matches to this, but any of these matches that share a common line with me are going to share all the SNPs from that common line going back into time. So we're going to share a lot of SNPs, but those aren't that important for this analysis purposes. Then we have these that are in the middle, and these are what I call subclade SNPs here. They are shared by more than one person, but they're not shared by the whole group. So they are the ones that are more interesting because they define branching within the tree itself, within this group's tree. So, for instance, SNP 1 is shared by me, match 1, and match 2. SNP 3 is only shared by match 1 and match 2. So these are the ones that I want to look at in order to determine the branching that happened within the structure. The private SNPs may be interesting later if I want to do age analysis on the group, or if I want to try to see if I want to test other people in order to see if they match those SNPs or not. But for the purposes of trying to draw a tree with this group, they're not that useful. So if I switch back over to my tool, I have tables that have read and determined the subclade SNPs and the private SNPs for all of the kits that had SNP data in this group that I just read in. So what you see in these columns, it gives you the SNP label. If the SNP is named, it will be in yellow. It will have its name in yellow. If it's unnamed, it will just be called by its position reference. It has the position reference for all of these SNPs automatically filled in. And then it goes through and it tells me if they were positive or if they were negative. And if it was unknown, there would be a question mark and it would be a gray box. So it's sort of the same output as you see in SAP, but in this case, it's just giving you the indication of the SNPs that were found in the CSV files. And then it does an assessment against 4 definitions of quality as to whether or not that SNP is found in a quality region. There's a lot of debate About the term quality, it doesn't mean the SNP itself is bad. Sometimes they're just hard to read. Sometimes those are recombinant areas of the Y chromosome, which means they could have come over from the X. And so there's a lot of genetic reasons why those may not be good ones to look at from a Y chromosome perspective. But anyway, these are an indication of whether that SNP should be used or not. If you remember, one of my checkboxes was to only include SNPs that are in the quality regions. What that does is it will limit this report to only SNPs that are found either in the COMBED, in the McDonald regions, or in the full POSNIC regions, which is a bigger area. The last one, the YSEQ definition, is really more of a definition of what they will take in order to produce their primers to test SNPs in the first place. So it's really more of an indication. It's the widest of the definitions of quality, but that's because YSEQ isn't saying that it's a bad SNP. They're just saying that they can't produce a primer to test for it. One of the things that I want to point out here is that the CSV files sometimes can contain bad information. This SNP here, L1120, is actually an upstream SNP that all of these kits should be positive for. But for some reason, the SNP file for 80341 shows that it's negative in that kit. If you look at the results on FTDNA's webpage for 80341, it shows negative for this SNP. That's not possible because the SNP is upstream, and that's been proven through lots of other matches, but it's still reported that way, and you may find those. If you run them through SAP, it may give you consistency check errors. It would in this case, and so I had to eliminate that SNP manually after I discovered that. It's in all the quality regions, so it's not a bad SNP, but you have to be open to the fact that these reports, you may find some of these SNPs in these reports that have to be excluded for other reasons. Sometimes the read itself wasn't reliably called in the data, but it gets reported that way, and you have to double check those. So be aware of that. If you do get consistency checks in your data, it's probably because SNP was reported incorrectly in the CSV file, and it needs to be double checked. You can report those to Family Tree DNA, and they'll check them and they'll correct them if necessary. So that's one way to do it. Then you get these output of your private SNPs. A lot of these are often unnamed, but not always. There are two here that happen to have labels, and it shows you which of the kits it's positive for. Now, if I scroll down and I get the input file, it's going to download, and I click on that, and it gives me two sections. I get the STR data, so it tells me how many STRs it pulled in this comment field, and then it gives them all. I have my 561 here. It has done all the translation of the numbers correctly. It's pulled apart the multi-copy STRs. It's changed any that were not called to ends, which is what SAP needs, and so on. And then down here at the bottom, I've got my SNPs already formatted correctly with the positives and the negatives that I can run through my tool. If I do run these through SAP, I'll show you what that looks like. Here's the screen. Here's the output from SAP that took that run. I did eliminate L1120 because that's a bad call in that file. But otherwise, it has the STRs here that it read in, and then the SNPs are in this format. Because I've mixed both kits that have SNPs and ones that don't, it has said that it can determine branching from the STRs, but then in some cases it can't tell if the SNP was actually private to me or if it might have also occurred in this other kit that looks like they're closer to me. I'm N39890 here, by the way. So that's a good indication that I may want to test those SNPs in this kit, either get them to upgrade, obviously, or I can test those individually if I think maybe they're potentially positive in that other kit. But here's the branching that it determined from the SNPs itself, and it's put the STRs on top like it usually does. Now, one thing I'll mention about the input file that's created by the CSV Analyzer tool, it only has the STR data and the SNP data sections. It doesn't have any of the other sections, the info, the gen data, any of the modals, anything that you might have added yourself in some of the SAP input files that you've created. There's none of that in here, so you'll have to add those in yourself. Those are all options that you can add in if you want to improve the tree output, and you can add those yourself once you get more comfortable with SAP. One more thing I'll show you. If I go back to my tool, I reran the CSV analysis tool and I unchecked those two options. So if you remember, the options were, the first one was to only show the SNPs that are in the quality regions, and the second one was to only show SNPs that were found in all kits. So now it's producing some tables that show some additional SNPs. In particular, my subclade SNP table now has an extra one in here that's not in any of the first three regions. That one turns out, because I've done some analysis on it, it's not useful for phylogenetic purposes, but you can try this on your own set and see if, even if it's not in the quality regions, it may still be useful for you. So I wouldn't completely rule them out, but you have the option to report them or not in the file. And by the way, if you do report them in the table, they will be found in the SAP input file that you generate. If you don't choose to include them, then obviously they're not in that file either. But the input file that gets created will match these tables. The second thing that it produces is a potential subclade SNP table, where it was not read. These SNPs were not found in at least one kit, but their status in the files that they were found in suggests that they might be subclade SNPs for your group. Now, a lot of these are also, because I unchecked both selections, are also not in the quality regions, sometimes not in any of them. So for my purposes, I might want to know about these if they were not found in all kits, but I would probably not want to use the ones that are not found in the quality regions. So, you can make up your own mind here. That's why the tool allows these as options, so that you can take a look at this. I will say there are a lot of these. You'll find this will usually produce a lot of output if you uncheck both of those checkboxes. A lot of these SNPs are probably upstream. They just haven't been found in all of the kits, and since the tool doesn't know, it's giving you the option to analyze them further if you want to. Then it shows you the private SNP table again. Here we have one extra SNP that was added in to this table that's not in any of the quality regions. It's a potential one that might be useful. And then I have a potential private SNP table. These are all the SNPs that are not in the quality regions, because I unchecked that one, but also that were only found in one kit. It's just that they don't know, the tool doesn't know if they are private or not, because they were not called in some of the other kits. So again, a long list of these, and you get down here, and in some cases, you get this kind of thing reported. Now, this is in the CSV file. It's an RS position, which is not a SNP name. It's a position in the Y chromosome. The tool calls them out in these tables when it finds them. I would ignore them myself, but you could investigate them further as to why they're being reported in the CSV files. I'm not even sure as to why. I think it's a mistake, but if you see them, you want to investigate further. These are positions on the Y chromosome, like I said, and they might indicate SNPs, but they don't match the right format for the tool to analyze. So if I did get the SAP input file for this run, it will have a lot of SNP. When I scroll down to here, it's got a lot of SNPs put in here because it puts all of these in. You can run it this way. It may not be consistent because all these SNPs that are reported that aren't in the quality regions may not be phylogenetically consistent, so they may give SAP some trouble. It will report them, and it may be able to finish or may not. I'm not going to try this run because it's not going to be very meaningful. It will probably produce most of these SNPs as potential group SNPs that are true for the whole group, and it will show them all under the group MRCA, and you'll have just a long, big string of labels under the group MRCA, especially for all these where they're positive for at least 2 people. And so it's probably not terribly useful to uncheck both of those options and report on all of them and then run that through SAP, but you can do it if you want. I usually use the version of the run that has these two unchecked just to double check if there's any SNPs in those lists that I think I might want to look at further. It gives you a little bit more useful information than the first run, so that's up to you. That's the tool. That's the CSV analysis tool. Hopefully that'll be useful to you if you have a group, especially as people get more Big Y 700 results in and they need to analyze a group of people that are closely related. It would make sense to use this tool to automatically generate the /str data and /snp data for your SAP input, and then add to it with the other optional fields, the other optional sections of the input data. And for more information on those, please refer back to the SAP videos that explain about the SAP tool itself. Thank you for listening.